Good morning to Ananda. I am Dr. Jaganmohan Jinnalagadda. So we are in lecture 13 of Advanced Statistical Methods. The course number is Ba Zg524. So in the last lecture, we started studying non-parametric methods. I'll give a small revision of what we had in the last class and will complete non-parametric methods in today's class. Moreover, we will also try to complete an interesting topic called simulation. So maybe in the next lecture, that is in tomorrow's class, we will complete forecasting techniques. So with which we complete 14 lectures. In 15th lecture, we try to discuss discriminant analysis, cluster analysis and factor analysis in short in a lecture, because we don't have any problems to solve in those. It's only a theoretical study, because whatever the problem we are going to study in those areas, we have to use a Minitab software or SPSS or something which are not in our area. So that's why we just only discuss what are the important characteristics of those three topics quickly and what are the applications. And in the last class, that is in lecture 16, I want to revise a few problems which are important models for our main exam. So your main exam is a open book exam, so no need to by heart any formulae. And also anyhow you will bring your Anderson textbook for open book examination. So what I want to tell you is like, what are the important models which we need to concentrate for main exam. So in those 2 hours class in lecture 16, I'll give a detailed uh, explanation of different methods which we need to concentrate for our main exam. So right, so we'll go to our non-parametric methods lecture. So lecture 16, next Saturday is lecture 15 and the next Saturday is lecture 16. So we have 5 non-parametric methods in our chapter, in which we have already done sign test. So how do you attempt sign test? We know that we have 2 applications of sign test. So what are the 2 applications of sign test? One is a test about a population median, and second one a matched sample test about the difference between two populations. So we did both problems in sign test. One is testing about a population median. So we did in 2 cases. Small sample case, that is less than or equal 20, and large sample case, that is about 20. Similarly, matched sample test about the difference between two populations. So we will given two samples corresponding to two populations. So we have tested using sign test. Here also we have a large sample test about 20 and small sample test less than or equal to 20. So we did all these things. So the interesting point is that, so in testing about a population median, you will write H naught as population median equal to so and so, and HA as population median is not equal to that number. Then it becomes a two-tailed test, and correspondingly you will write H naught for P as P equal to 0.5 and HA as P is not equal to 0.5. Then your sampling distribution follows binomial distribution with P equal to 0.5. What is your test statistic? Your test statistic is the number of positive signs. How do you give positive signs? For all those data points above median, you will give positive signs. For all those data points below the negative sign, you will get negative sign in the sample. Then we discussed Wilcoxon signed rank test. So what is the importance of Wilcoxon signed rank test? So the Wilcoxon signed rank test is useful. Is useful? Yes, please. Is there any difference between the two population medians or not? So the Wilcoxon signed rank test says that is there any difference between two population medians or not? So obviously what you will write in your H naught, there is no difference between the two population medians, and HA as there is a difference between two population medians. So here the concept is like slightly confusing, but you please concentrate. It is not that much tough because this problem we have already discussed in the last class. Just go through the slides one more time. You can easily understand. So now in today's class, we will complete the remaining three tests. The third one is Mann-Whitney-Wilcoxon's test. So far we did sign test. Sign test is to test the hypothesis that the population median is something. Or matching samples test, where we have to test is there any significant difference between two populations or not. Whereas in signed rank test, we want to check whether there is any significant difference between population medians of two populations or not. Now, in the third one, Mann-Whitney-Wilcoxon test, this is also another non-parametric method. It is also discusses is there any significant difference between two populations or not, like sign test. So this test is based on two independent samples from two different populations. So advantage, uh, probably no. So advantages of this procedure are it can be used with either ordinal data or quantitative data. Means it can be applicable in both ways. Similarly, it is a non-parametric test, right? So it does not require the assumption that the population have a normal distribution. So please remember that in non-parametric methods, we do not require any assumptions about population in many cases. So instead of testing the difference between the medians of two populations, this method is to test whether the two populations are same or not. Instead of discussing the medians, we will discuss only whether the two populations are identical or not. That's what the interesting thing here. So the alternative hypothesis, the populations are not identical, and the null hypothesis always a positive statement. The populations are identical. So let us take a simple example because all non-parametric methods are very easy to solve. Just only a simple concept only it is involving. So that's why I suggest you to practice all problems rigorously. So the example in Mann-Whitney-Wilcoxon test is manufacturer labels indicate the annual energy cost associated with operating home appliances such as freezers. The energy costs for a sample of 10 Western freezers and a sample of 10 Eastern freezers are shown on the next slide. Do the data indicate that a difference exists in the annual energy costs for the two brands of freezers? Which means that we want to check whether the two samples, whether the two populations corresponding to two samples are same or not. So how do you write that? Annual energy costs for Western freezers and Eastern freezers are same. Alternative hypothesis, annual energy costs are different. So what is the data I have given? I have given Western freezers population, I have a sample of 10, and Eastern freezers population, I have a sample of 10 observations like this. Now I want to use the Mann-Whitney-Wilcoxon test for a large sample case. So what is the procedure? What is the procedure? Just it's like just concentrate on this. Yeah. So we are this test is just based on whether the two populations are same or not. That is the only concept we need to concentrate. So the procedure of Mann-Whitney-Wilcoxon test is like this. First, rank the combined data from the lowest to the highest values, with tide values being assigned the average of the tide ranking. So you have to combine the data first and give rankings. And whenever there is a tide values, you have to give tide ranks. Then I am concentrating on the first sample. You can do it for second sample also. You will have the same answer. So I'm computing W. W means the sum of the ranks of the first sample. The sum of the ranks of the first sample is my test statistic W. Then what is the sampling distribution of W? W follows normal distribution. That's what the logic. So please remember, this is the very easiest of all. You have to combine data, then give rankings. Then calculate W as the sum of the ranks for the first sample. You can do it for second also, there is no worry. Then W follows normal distribution. So now, what is the mean value of the W statistic? It is N1 into N1 plus N2 plus 1 by 2, because anyhow it is an open book. There is no worry of remembering this formula. And standard deviation is square root over N1 N2 into N1 plus N2 plus 1 by 12. Here I am talking like N1 greater than or equal to 7 and N2 greater than or equal to 7. I can treat it as a large sample in this case. In such a case, your W follows normal distribution. So now you see here, we have a data for Western freezers, first sample, Eastern freezers, second sample. But whenever we are applying this Mann-Whitney-Wilcoxon test, you have to give the rankings combinedly. So you have to mix the data and give the ranks. So you see here, the minimum is 53. So first rank is here. Then what will be the next? 53.20. Then third, 54. Then fourth. Fourth is in second sample, 54.10. Then fifth, 54.20. Then sixth, 54.30. Then seventh, 54.40. Then eighth. Eighth is 54.50. Then ninth is 54.70. Then 10th, 54.90. Then 11th, 55. then 12th 55.10, then 13 55.20, then 14 55.40, then 15 and 16 there are tie here because 55.50 and 55.50. So you have to tie the rank. So 15 and 16 are tied. So 15 plus 16 by 2. So 15.5, 15.5. 15, 16 are next 17. So where is the 17th rank? 55.80. Next 18th, 56. Then 19th, 56.10. Then finally, we should have 20. So like that, you have to give ranks in the combined data, of which you have to calculate only the sum of ranks in the first sample. That is W. So that is 86.5. Then you have to calculate the mean of W. That is UW. What is the formula? Half into N1 into N1 plus N2 plus 1. So N1 is 10, N1 plus N2 is 20 plus 10. And what is the standard deviation? Square root over 1 by 12 into N1 into N2 into N1 plus N2 plus 1. Very easy to remember, but anyhow not required for open book. So after calculating mean and standard deviation, you have to apply the rejection rule. So what is the rejection rule? So if you use 0.05 level of significance, reject H0 if p value is less than or equal to 0.0. So calculate the test statistic P of W less than or equal to 86.5. That is probability of converting into Z. 86.5 minus mean is 105 by standard deviation is 13.2. So you got probability of Z less than or equal to minus 1.4. So P value is obviously for a two-tailed test it is twice. So twice of 0.0808 because this value is 0.0808. Then the answer is 0.1616. So if you compare with rejection rule, so what we can say, the P value is above alpha. So we cannot reject H0. So that's why there is insufficient evidence in the sample data to conclude that there is a difference between the energy costs with the two brands of free cells. So like that we have to complete this problem. So do you think that this is very tough? Yes or no? It's very simple to calculate. Any questions? Shall I move further? Good. Ranking, yeah, ranking, you have to take care of that. Yeah, ranking, you have to take care of that because combined ranking is the main problem. You have to be cautiously write the rankings for each and every observation. Because the question is that my suggestion is like this. Don't combine the data just like what we do generally. You have to write the table like this, but carefully observe the rankings. That's it. Yes, sir. So just write the table as it is, but meticulously observe each observation. That will be more nice. So the Kruskal-Wallis test is the fourth test which we are going to deal with. The previous test is what? It is a Mann-Whitney-Wilcoxon test. It is only for two samples or two populations, whether the two populations are identical or not. But Kruskal-Wallis test is a generalization of Mann-Whitney-Wilcoxon test. Means we are comparing three or more populations in Kruskal-Wallis test. So we want to check whether three or more populations are identical or not. So that's why Kruskal-Wallis test can be treated as a generalization of the Mann-Whitney-Wilcoxon test. But do you know, so maybe from our long time memory we can recall that whenever we are comparing three or more populations, our test statistic always follows chi-square distribution. Do you remember? So whenever we take the comparison of three or more populations, generally we take chi-square distribution as our sampling distribution. But whenever we introduce chi-square distribution as our sampling distribution, then there is no concept of left-tailed test and two-tailed test, only upper-tailed test. This logic I have already told you long back. So whenever we use a chi-square test for comparison, obviously we'll have a upper-tailed test only in the practice. So anyhow, I told you many times that this is an open book exam, so remembering formulas may not be tough for you. Textbook you will carry, so you can easily refer the things. Just you have to check which formulas are available at what place. That's it. So the Kruskal-Wallis test can be used with ordinal data as well as the interval or ratio data. Like Mann-Whitney-Wilcoxon test, Kruskal-Wallis test is also applicable for numerical data as well as interval data. Similarly, like the previous Mann-Whitney-Wilcoxon test, it does not require the assumption of populations are normally distributed. That is the advantage of non-parametric test. So what is the test statistic here? It's a very complicated one. 12 by nt into nt plus 1 summation I runs from 1 to k ri square by ni minus 3 of nt plus 1. What is k? K is the number of populations, 3 or more generally. Ni is the number of observations in the ith sample. Nt means the total number of observations in all samples. And Ri is the sum of the ranks for the ith sample. Okay, so these are the four things we need to discuss. Okay, so shall I move further? Yeah. Yes, more than two, three or more. So when the populations are identical, the sampling distribution of the test statistic H can be approximated by, I told you already, chi-square distribution with k minus 1 degrees of freedom. What is k? K is the number of samples, number of population. So this approximation is acceptable if each sample size is greater than or equal to 5. This greater than or equal to 5 concept long back also we heard. If each sample size is above 5, then it is best approximation. So this test is always expressed as an upper tail test. That's what I told you. And the rejection rule is p-value less than or equal to alpha. So let us go through the example. John Knorr, director of athletics of Lakewood High School, is curious about whether a student's total number of absences in 4 years of high school is same for students participating in no varsity sport, one varsity sport and two varsity sports. The number of absences data were available for 20 recent graduates and are listed on the next slide. Test whether the three populations are identical in terms of absences. So use the level of significance 10%. So here also you want to check whether the three populations are identical with respect to the absences, the characteristics. So this is the sample we have. No sport, one sport and two sports. Okay. So have you observed any interesting thing in Mann-Whitney-Wilcoxon test and Kruskal-Wallis test? Here there is no restriction that the sample sizes are same. Yes or no? Correct? Not required. Yes. populations are identical means it doesn't mean that samples are also identical, right? Populations are identical means populations are following the same property with respect to a characteristic. That's it. Identical with respect to a property. So, whereas if you take the Wilcoxon signed rank test, the second test, there we are taking pairs of observations and calculating their differences. So, in such a case, you should have an equal number of uh, elements in each sample. Otherwise, how do you take pairs and their differences and ranking and so on so? So that's why for median type of things, generally we should have same sample sizes. Like Wilcoxon signed rank test, you should have same sample sizes. Whereas in Mann-Whitney, Wilcoxon test and Kruskal-Wallis test, it can be different. So now let us rank them. So it's a very lengthy job. So let us think here. So no sport, first sport and two sports, let us rank them. So 6 is the minimum. So 1 here. After 6 we have 7 here. 7, there is no 8, 9 here. After 9, 10, 10 here. Then 11. Then 12. But here what happens? We have 2 12 seems to be. So which ranks we have to share? 6 and 7. So that's why 6 and half, 6 and. After 12 do we have 13? Yes. Yeah, you have to take the average of 3 ranks. 8, then 14, no 14, 15, 14 is there here, 15. Now here you see 15 is matching. So 15, I think we have two 15s here and here. So you have to take the average of 10 and 11. So 10.5, 10.5. Then you have 16, yeah, 12th rank because after 11, 12th. 17, yes, 13th rank. 18th, 14th rank. 19th, 15th rank. 20, do we have 20? But I seems to be 20s are 2 here. So what rank we have given lastly for 19, 15. So you have to average 16 and 17 by 2. So 16 and half, 16 and half. So 16, 17 over, then we have to give 18th rank. Do you have 21? 21, yes. 22, yes. Then 23, no, only one is left, that is 27. So yes, so we have given all ranks. Now please add ranks for each sample. So this is first one, this is sum of second one, this is third. So what is the test statistic? Reject H naught if you use the test statistic concept. Reject H naught if chi-square is greater than or equal to 4.60517 for 2 degrees of freedom. What is this? This is the table value of chi-square for 2 degrees of freedom. So if it is about table value, generally we reject H naught. Or if you want to use a p-value method, reject H naught if p-value is less than or equal to alpha. So we have k is number of populations 3, n1 is 6, n2 is 7, n3 is 7 are the respective sample sizes. Nt is the total sample size. This is combining all three. So H formula is 12 by Nt into Nt plus 1 summation I runs from 1 to K Ri square by Ni minus 3 into Nt plus 1. If you substitute them, we are getting 0.3532. Yeah. Is it so 9.2? I'll check that. If it's so, I'll check that. Just a moment. Yeah. So that I'll concentrate. I'll come back to this. So the value is coming out to be 0.3532. So H value is 0.3532. Okay, thanks. So 0.3532. Yeah, 0.3532 is below the table value. 0.3532 is below the table value. So we cannot reject H naught by using the critical region approach. If you want to use a p-value approach, you can use the other method. I have given critical region approach. If you want, you can calculate the p-value also, and please do it. P-value also you can calculate that. Yes or no? So you can apply p-value approach or you can apply critical region approach to tell the answer. I am using critical region here to finalize it. Any other queries? Yeah. So I'll move to the last concept known as rank correlation. Long back during our childhood days, one might have come across this method called rank correlation coefficient. Now we are again discussing them because it is also a non-parametric method. But in addition to the rank correlation method, we will also test the significance of rank correlation. That is an added point here in our syllabus. So the last topic is rank correlation. So what is the rank correlation? Of course, it gives a correlation coefficient between ranks rather than the observation. Okay. So long back you might have come across the Pearson's correlation coefficient R. That is the correlation coefficient. So the Pearson correlation coefficient gives a numerical relationship between two variables when the data is in the form of numeric, that is interval or ratio data. But when the data is in ordinal one, then you cannot use a Pearson's correlation coefficient. In such a case, we use Spearman's rank correlation coefficient, that is RS. So please remember the Pearson's correlation coefficient gives a numerical relationship between two variables provided the data is in the form of numericals, that is interval or ratio. Whereas Spearman rank correlation coefficient also gives a measure of association between those two variables provided the data is in the form of ordinal. So as usual, like correlation coefficient, the Spearman's rank correlation coefficient also lies between -1 and +1. If values near 1.0 obviously indicate strong positive association between the ranks, and -1.0 says strong negative association between the ranks. Yes, sir. No. Pearson's correlation coefficient also lies between. You are talking about R square. The R square is the coefficient of determination. So the formula of Spearman's rank correlation coefficient is given by 1 minus 6 sigma d square by n into n square minus 1. 1 minus 6 sigma d square by n into n square minus 1. N is the number of observations being ranked. Xi means the rank of observation I with respect to the first variable. Yi means the rank of observation I with respect to the second variable. And Di means the difference in the ranks. So N, Xi, Yi and Di are important in formula. 1 minus 6 sigma d square by n into n square minus 1. So, but maybe due to the advanced nature of our course, no. Two samples, like one sample from each population. Two, right? And they should be having same size. Otherwise, how do you calculate the difference in the ranks? Yes or no? Now, this is an advanced course. We need to test the significance of rank correlation coefficient. So that's why we may want to use sample results to make an inference about the population rank correlation coefficient. That is common in nature. Because whatever we are calculating, Spearman's rank correlation coefficient is always for a sample data only. Because in our advanced course, we want to test the inferences about population Spearman's rank correlation coefficient also. That's why what is our test? H naught is PS is 0, means there is no rank correlation. And alternative hypothesis, there is a rank correlation. Please observe the difference. This RS is for sample and PS is for population. Okay. Now we want to discuss the sampling distribution of RS, because RS is your test statistic. So sampling distribution of RS under null hypothesis. So mean is 0 and standard deviation is square root over 1 by n minus 1. You should remember the formula. So your statistic is RS. RS's mean is 0 under null hypothesis and standard deviation is 1 by root over n minus. And you have to assume that RS, our test statistic, follows normal distribution for n greater than or equal to 10. So I'm giving you a question. Sorry. Crenner Investors provide a portfolio management service for its clients. Two of Crenner's analysts rank 10 investments as shown on the next slide. Use rank correlation with alpha equal to 0.10 to comment on the agreement of the two analysts' rankings. So already they have given ranks, so no need to bother from our side. If not, you have to give ranks. So that's why anyhow ranks are provided in the problem, means more comfort. We will do one more problem during our revision class where we will give data, you have to calculate ranks. That I will solve one more time in the revision class. So here I am providing ranks directly. If we have ranks directly, then our job becomes more simpler. So again they gave ranks. What do you need then? You need only calculate the difference in the ranks, that is D. So what is your null hypothesis? Population rank correlation coefficient PS or rho S is 0. And alternative hypothesis is population rank correlation coefficient is non-zero. So we have, yep, this is a Spearman's rank correlation, means Spearman's only. Correlation means Pearson. Spearman is the author who have given rank correlation. Pearson is the scientist who have defined the correlation. Yes. So we have rankings for first data and rankings for second data. So just calculate the differences. So 1 minus 1 is 0, 4 minus 5 minus 1, 9 minus 6, 8 minus 2, 6 minus 9, 3 minus 7, 5 minus 3, 7 minus 10. Yes, yes, yes. Uh, I'll just add a point, just wait for a while. 2 minus 4 and 10 minus 8. So difference square you need to calculate. 0 square, minus 1 square, 3 square, 6 square, minus 3 square, minus 4 square, 2 square, minus 3 square, minus 2 square, and 2 square. Total you add. This is sum of the ranks. So you have to check the mean and standard deviation of your test statistic. Your test statistic is RS, its mean is 0, and standard deviation is square root over 1 by n, means sample size 10 minus 1. So rejection rule is reject H naught if p value is less than or equal to alpha. So calculate the rank correlation coefficient RS. RS is how much? 1 minus 6 sigma d square by n into n square minus 1. That is 1 minus 6 into sigma d square. Sum of the squares of the deviations. How much it is? 92. By n is 100 into n square is 100 minus 1. So you got 0.4424. Calculate the test statistic. RS minus its mean by standard deviation. Mean is 0, standard deviation is 0.3333. So you got set. Then calculate p-value. Because it is a two-tailed test, you have to calculate it twice of the ranking. So 2 of 1 minus 0.9082. So you got 0.1836. Okay. Then, so p-value is greater than alpha. So what happened? P-value is greater than alpha means we cannot reject H naught. Yes, correct. That's the answer. So this is the rank correlation coefficient. Yeah. So the question is that in this question, assuming the data is ordinal and I gave ranks for two different samples. But sometimes when I give an ordinal data and you have to rank it, then it is a little confusing. That problem we will do in the revision. But what I want to tell you that in this problem, assuming the data is ordinal and have provided ranks for two different samples. That's what the logic here. I have already assumed. Yes, yes. Sorry, you are mistaken with the concept. Spearman gives correlation coefficient between ranks. Pearson gives correlation coefficient between the data points when the data is in the form of numericals. Pearson's rank correlation coefficient is the correlation coefficient between data points when the data is expressed in numericals. Spearman's rank correlation coefficient, the name itself says that it is a correlation coefficient between ranks, not between the data, because here the data is in the form of ordinal. That's what we have assumed. You please think rank correlation coefficient. The name itself says that correlation coefficient between ranks. So whenever you write, you have to give a distinction between these two words: correlation coefficient, rank correlation coefficient. Correlation coefficient means it is the coefficient of correlation between the two sets of data points when the data is expressed in numerical. Rank correlation coefficient name itself says that you are obtaining correlation coefficient between ranks. Okay? Yeah. So now tell me any other queries in the non-parametric tests. Any other queries in the non-parametric test? Yeah, I'll give one more set of problems during my revision class because I concentrate more on non-parametric tests as well as few more problems on simulation and forecasting that will take 2 hours of our time, and few problems on multiple regression and logistic regression. So I want to give these problems on that day. Any other queries? So I think I'll take a that problem we will give. Don't get confused, but still also the keyword is important. I told you the first test, sign test, it has two applications. First one is testing about population median. Second one is matching sample, means to test the difference between the population. Wilcoxon sign rank test to test the difference between the population medians. Third one, Mann-Whitney-Wilcoxon test, whether the populations are identical or not. Crystal Valleys test, whether the populations are identical or not. Finally, rank correlation coefficient. I don't think that there is a confusion in identifying the test, but anyhow we'll provide you what test you have to use. But think once, isn't it confusing? Yes. Thanks for this. So if you have any further queries, you just ask me, or I'll take a small break and I'll come back with a simulation concept. Yeah, thanks.